Okay, today we are going to be talking about trig functions in radians. So we know how to evaluate trig functions when they're in degrees, but now we want to practice doing that when radians are involved. The first thing is we're going to talk about the most common radians. So the first one is if you imagine the unit circle here, and if we divide it into 8 pieces, we know, for example, that this first section is pi. So if we cut that in half and we get this section here, that's going to be pi divided by 2. And if we then cut that in half, we can see that's going to be pi over 4. This is 3/4 pi, and the rest kind of happen similarly. And again, don't forget that an entire circle is 2 pi radians. So pi over 4 is the radian version of 45 degrees. So this is basically all of its relatives. Here, if we're looking at the unit circle divided into 12 pieces, then you can think of it as 2 pi being divided into 12. That means that each section is going to be worth, or is going to be pi over 6. So this first section is 1/6 of a pi, which makes sense because you can see this is a whole pi, and so this is 1/6 of it. Then as we move along, we can see that we have 2 pi over 6, which reduces to pi over 3. Then 3 pi over 6, which reduces to pi over 2, etc., etc. You can see as we go around, we get to 6 pi over 6, and eventually 2 pi. So as you can see, they kind of alternate between having a denominator of 6 and having a denominator of 3. So those are the angles that we're really interested in. Please don't memorize every single one of these angles. There are some really confusing images out there that have all of these angles on there, and so it's divided up like that, and you have to memorize tons and tons of angles. Honestly, that's not the easiest way to do it. Do not memorize the angles. I will teach you a better method in 1 second. So these are the 3 main ones. You can see that our smallest angle, which is our 30 degrees, is pi over 6. Our next smallest is pi over 4, which is the 45. And then our next is pi over 3, which is 60 degrees. A really common mistake is I think that students see the number 6 and they know that it's a bigger number than 3. So they think that pi over 6 is the bigger angle. But it's definitely not. You know that 1/6 is less than 1/3. So how can we update our special triangles now? So these are the same exact special triangles that you've seen before. The only difference is that instead of 45 degrees, we now have pi over 4. And instead of our 60 degrees, we have pi over 3. And instead of our 30 degrees, we have pi over 6. But they work in the exact same way. The ratios work in the same way, the triangles work in the same way, everything is exactly the same. So because I told you that you don't need to practice or know where every single angle is, this is the way that you can kind of tell how to use the cast rule. So, for example, 5 pi over 4. That's a little bit confusing. So how I like to think of it is I think, well, 4 pi over 4 would be like a full pi. And 5 pi over 4 is just a bit more than a full pi. Therefore, it's in quadrant 3. Again, the reason why we're doing this is because we care about what quadrant an angle is in because of the cast rule. So similarly over here, again, I'm thinking, well, 7 pi over 6, that's almost 6 pi over 6, again, which is just pi. So 7 pi over 6 is just a bit more than pi. So it is once again in quadrant 3. So this next one, 2 pi over 3, I'm kind of almost rounding it to the nearest one. So this one, 5 pi over 4, the nearest whole number was 4. So that's why I rounded that one down as opposed to rounding it up to 8 or something. And here, I'm rounding it up because I can see that the closest one is 3 pi over 3. So 2 pi over 3 is a little bit less than a full pi. So that's why I know that it's going to be in quadrant 2. This one, again, I'm kind of rounding to the nearest whole number. So the closest one here is 8 pi over 4. If you reduce that, you get to 2 pi. So 7 pi over 4 is a bit less than 2 pi. So that one is in quadrant 4. This 3 pi over 2 is a bit of a weird one, but if you think of it this way, that we know this is pi over 2, this is a full pi, therefore this is 3 pi over 2. So it's not in a quadrant, it's actually a boundary angle. 3 pi over 2 is 270 degrees. So it's not in any quadrant at all, so it'll be one of those special cases. And our last one here, 11 pi over 6. If I go up to the nearest whole number, that's just a bit less than 12 pi over 6. So it's a bit less than 2 pi. So now that we know how to find what quadrant angles are in, we are going to use that knowledge to figure out the exact value of each of the following. So cos of 3 pi over 4, the absolute first thing you should do is draw it. The reason why I know 3 pi over 4 is in quadrant 2 is because, again, 4 pi over 4 would be this full one, so it is a bit less than that. The next thing you need to do is figure out your related acute angle, and this is exactly what you would do if you were dealing with degrees. The convenient thing, though, is that you can figure out the related acute angle just by looking at the denominator here. So, for example, if we had 5 pi over 6, its related acute angle is pi over 6. If we had 3 pi over 7, well, that's already acute. Let's say 13 pi over 7, then its related acute angle would be pi over 7. So that's one of the convenient parts about radians is that you can tell the related acute angle. So rather than having to do, 225 minus 180 is 45, we can actually just look at the question itself. So we draw it. We know cos of 3 pi over 4 is going to be related to cos of pi over 4. And because it is in the S quadrant, we know it is going to be negative. And we can either use our special triangles or whatever other method we want. Keep in mind that that's the same as -1 over root 2. I don't have a preference for which one you use. Okay, the next one, we always draw it first. So 5 pi over 3 is a bit less than 2 pi. So it's in the C quadrant. Again, its related acute angle is pi over 3. So we know that sine of 5 pi over 3 is going to be related to sine of pi over 3. And the reason, again, why it's negative is because it's in the C quadrant. Now, when you're finding sine of pi over 3, remember that what you need to do is look back up at the special triangles. So sine of pi over 3, we can see right here is root 3 over 2. You can either use your chart or you can see, again, pi over 3, sine is opposite over hypotenuse, so that's why it's root 3 over 2. Next, we have tan. So 5 pi over 6 is a bit less than a full pi. We know its related acute angle is just this right here. So we know tan of 5 pi over 6 is related to tan of pi over 6. And again, it's negative because it's in the S quadrant. Cos of pi over 2 is a boundary angle. So unfortunately, we can't use our special triangles for this. Instead, we can use our XYR definition. If you remember, cos is x over r. And then you can consider this point, you're imagining that it's like a point on the unit circle. So the point 0, 1, x would be 0, and r is the radius, which is always 1. So that's why this particular one would be 0. If it helps, you could also think of it as, if you know what the graph looks like, you can imagine that pi over 2 is right here. We will be looking at the graphs and radians in the next lesson. The coordinates, oh, sorry, my writing got messed up here. The coordinates of the point at 11 pi over 6 radians. So don't forget that the coordinates are given by cos theta, sine theta. So really this is just asking what's cos of 11 pi over 6 and what's sine of 11 pi over 6. So again, cos of 11 pi over 6, the related acute angle is just pi over 6. We draw it, we can see that it is a bit less than 12 pi over 6. So that's why it's in quadrant number 4. We can also then say that it's cos of 11 pi over 6 is related to cos of pi over 6. Sine of 11 pi over 6 is related to sine of pi over 6. Because it's in the C quadrant, this one is positive, and the sign is negative. And again, I find cos of pi over 6 from a special triangle and sine of pi over 6 from a special triangle. This one, keep in mind that if you have something like sine squared theta, that's the same as sine theta all squared. So therefore, if you're doing sine squared of 7 pi over 4, you need to find sine of 7 pi over 4 and square that. Here again, I'm using the fact that pi over 4 is a related acute angle. I also know that it's in the C quadrant because 8 pi over 4 would be the full 2 pi. Then we know it's negative because it's in the C quadrant, so we square these values once we get it. Remember, squaring a number makes it positive, and adding these together gives us 1, and that actually makes sense because sine squared plus cos squared is equal to 1, as long as these two angles are the same. And we'll see that again in Unit 4, although you saw it last year as well. Okay, thanks for joining.